Hi and welcome to Maths class. What we're going to look at in this video is one worked example of solving problems using the normal distribution. So when you see the word solving problems, it usually means we're not just given values, we're given some kind of real world context and we've got to pull the values out that are important. So I'm just going to read through the question at the start. Shoelaces sold as 50 centimetres are manufactured at a certain factory. However, the lengths actually follow a normal distribution. Okay, so this is a normal distribution. Now remember, in an exam, I'm not going to be in the chapter called normal. So I'm looking for these keywords to tell me, all right, I'm going to use the normal distribution. And the mean is 50 centimetres. I'm going to jot that down over here. Mean is 50 centimetres. Quality control managers at the shoelace factory check the lengths of all laces manufactured and follow the rules below. 1, if a lace is greater than 53 centimetres, it's classed as oversize and sold as a 55 centimetre lace. 2, if a lace is smaller than 47 centimetres, it's classed as undersize and sold as a 45 centimetre lace. And finally, if it's between 47 and 53, it's classed as adequate and sold as a 50 centimetre lace. So the first thing I need to do is define my variable. Let x be, well, it's going to be the length of the shoelace. Of a shoelace. And it's going to be measured in centimetres. And therefore I know that x is binomial, x is normal. As I'm told in the question, x is normal, the mean is 50, standard deviation and variance are unknown. And in fact, if I go to question 1, the first thing I need to do is find the standard deviation. So this part of the question is going to look very similar to the previous example that I did, but I don't have any of the information yet. I've got to go back and sort of work through this and see what I've got. And the easiest way to do that is with a sketch. Another reason, so there's 2 reasons to do a sketch. One is that it helps you to make sense of the information, but the other is it counts as working. If an examiner is looking for some working and you've done a sketch, that's your working. So there's my normal curve. The mean is 50, and I know that I've got these important boundaries at 53 and at 47. And that if I'm to the right of 53, I'm oversized, and if I'm to the left of 47, I'm undersized. But importantly, I also know that this area in here is 0.9 because that's given to me here. 90% of laces are adequate. Adequate means it's between 47 and 53. So 90% of laces are going to fall within this range. I can now use symmetry to work out that the probability of being oversized is going to be 0.05 and the probability of being undersized is going to be also 0.05. Now the reason I know that is because this 53 is 3 to the right of my mean and this 47 is 3 to the left of my mean. So I do have symmetry on this graph in terms of where these 2 boundaries are placed. Therefore I can assume that this area on the right here is the same as this area on the left here. So I've simply gone 1 minus 0.9, which gives me 0.1, and I divide it by 2 to put half of it over here and half of it over here. Okay, but what I'm going to do now is I'm going to do something similar to what I did in the previous question. I'm going to transform these onto my standard curve. So let's just do a quick sketch to see what that looks like. Oops. Not quite, but that'll do. That's going to be those 2 values. That's going to be my mean, but my mean is now going to be 0, okay, because this is the standard curve now. This is the Z curve, all right, whereas this one is the curve of X. So how do I transform? Remember that I've got a Z value is equal to the x value minus the mean divided by the standard deviation. I'm always going to use this equation. So this value here is going to become 47 minus 50 over the unknown standard deviation. And this value here will be 53 minus 50 divided by the unknown standard deviation. This one I know is going to be 0, but how would I get there? 50 minus 50 divided by an unknown standard deviation is still going to be 0, okay? I can't mark the standard deviation in this graph yet because I don't know where it sits. I don't know where it sits on the X curve either. But now what I can do is, first of all, I'm going to use this to write down a probability that I know. I've got a few options here. I'm going to go with this 47 value. I know that the probability that X is less than 47 is 0.05. I've just worked that out using symmetry, and the working, if I need any, is here on my diagram. So now I transform that into a Z value. The probability that Z is less than, well, that's this value here, 47 minus 50. And I'm writing it out rather than going straight to the answer of that. The simplified version is going to be 0.05 because this area here is equal to this area here. So now I just need my calculator, and I can simplify this. 47 minus 50 will give me -3 over sigma is equal to, well, this is the power of transforming onto the Z curve, is I now have a known standard deviation and mean. My mean is 0, my standard deviation is 1, which means when I ask my calculator, what's the boundary such that the probability of being to the left of that value is 0.05, my calculator can answer that for me, and then I'll have a little equation that I can solve. So let's bring up CAS, and let's do this. So I'm going interactive. I've got a known probability and an unknown boundary value, so that gives me an inverse. I need to use the inverse, and I'm in the normal. And so I'm going to leave this 1 and 0. I'm going to leave it being a left tail because I said Z less than, which means I use a left tail, and the probability is 0.05. Hit OK, and it tells me -1.6448. Now, once again, I'm going to write that down here, -1.4468. But when I do my calculation, I'm not going to use this rounded value. I'm going to use the value stored in my CAS. So this can be solved by calculating sigma equals -3 over -1.4468. And I'm now going to just do that. So I've got -3, and I know what my problem was last time. So I'm going to use my keyboard this time to enter my negative value because I'm typing. It's not the same as a handheld. Where's the negative on the keyboard? Can't find it. Okay, I'll just hit subtract and I'll get rid of that because I don't want it. So -3 divided by the answer that I just found is going to give me 1.8238. How many decimal places do I need? To 2. So that's 1.82. So let's jot it down. 1.82. And I'll write approximately equals here to make it clear that I have now done some rounding. I should actually write that here too. Okay. So I've done A, the standard deviation, and I'm going to jot it down up here only just to help me keep it. But usually the examiner doesn't look up here. The examiner looks at you working, and the last thing that you write is the answer the examiner's looking for. Okay, let's keep working on this. There's room to do B and C, and then I'm going to run out of room to do D, but that's okay, we'll make room. So B is easy because I've already done it. What is the percentage of oversized laces? That's 5%. Oversize equals 5%. And C, what is the percentage of undersized laces? I've already calculated that. Whoops, not understand. Undersized equals 5%. And finally, the probability of a lace being adequate given that it is not undersize. correct to 4 decimal places. It's not undersized. So I'm going to just shift all of this up to make myself some room, bearing in mind that I've got all the numbers and information that I need here. So I'll just keep that there, that question, but I've got space now. So what I'm calculating here is the probability that it's adequate. In other words, the probability that it's between 47 and 53. So 47 is less than x is less than 53, but given that it is not undersized, in other words, given that it is greater than 47. Okay. Now, I think I can do this without my calculator. What I'm really looking at here is the probability. Now, I need the intersection first. I've got to make sure I write all the working. The probability of 47 being less than x being less than 53 intersected with x is greater than, greater than 47. And I have to then divide it by this second probability. X is greater than 47. Okay. So the intersection of being between 47 and 53 and being greater than 47 is simply this, 47 less than x less than 53 over the probability that x is greater than 47 is going to be 1 minus 0.05, so 0.95. So what I've got is 0.9 over 0.95, and it turns out I will need my calculator after all just to do that part. So let's turn on Kaz. Oh, he's already on. You couldn't see all that. Let's show you that first. Okay, so make sure when you're doing these, oh, indeed, everything's hidden here. Let's just move me out the way. There we go. When you're doing these, you've got to make sure you put in all your working. So I've written down in probability notation the conditional probability question that's asked. And then I've written down, we know that the probability of A given B is the probability of the intersection between A and B divided by the probability of B. Oh, you can't quite see that now. Oh my goodness. Shift that just a little. There we go. So we know this formula. So all I've done is I've rewritten what's given to me in the question using the formula. And then I simplify the intersection of this and this has to be just this. Because if I'm greater than 47 and I'm in between 47 and 53, and both of those have to be true for it to be the intersection, then I'm in between 47 and 53. This I can put a value on straight away. Okay, now let's bring our Kaz back so that we can work out what that is. 0.9, hang on, try again. 0.9 divided by 0.95. How many decimal places? To 4 decimal places, 0.9474. So let's just move that out of the way. Oops, I'm moving the wrong one. There we go. 0.9474. Double check that. 0.9474. Yes, that is correct. Okay. So what I've done in this last example is I've had a conditional probability question. I've just used the formula and I've made sure I've shown all working, and I don't do any rounding until the last step. Okay, so that's the first worked example for solving a problem using the normal distribution.